Hello everyone, my name is Hongfei, a PhD student in State University of New York at Buffalo. Today I'm going to present our paper, DeepMV, Multi-View Deep Learning for Device-Free Human Activity Recognition. Recently, significant efforts are made to explore device-free human activity recognition techniques that utilize the information collected by existing indoor wireless infrastructure without the need for the monitored subject to carry a dedicated device. Most of the existing work focuses their attention on the analysis of signal received by a single device. In practice, there are usually multiple information sources available for the task of activity recognition, as shown in this figure. Each of these devices can be regarded as an information source and provide us a unique view of the observed subject. Intuitively, if you can combine the complementary information carried by the multiple views, we will be able to improve the system performance. To achieve this goal, we need to overcome the listed three challenges. First, the data heterogeneity. The data heterogeneity is caused by different types of signals and their different sampling rate. Second, the multi-view data fusion. Different sensors may carry different amounts of information. An ideal activity recognition approach should be able to capture the variance of information quality among the source and rely on more informative ones. Third, environment-independent recognition. The wireless signals arriving at the receiving device usually carry substantial information that is specific to the environment and the human subject. Our solution is our proposed DeepMV human activity recognition system. As illustrated in the image, the system is composed of three components: the data collection components, the data pre-processing components, and the data classification component. We collect various raw sensory data from heterogeneous wireless sensors in different environments and forward them to the data pre-processing component. After feeding the deep learning model with the pre-processing data, our system outputs the activity labels. Let's look closer to our deep model. It has a feature extractor to extract high-level features from heterogeneous data and fill them into a combined representation. The model also has an activity recognizer to infer the human activity labels from the representation. And the model also has a domain discriminator to infer the domain label. In order to learn transferable features from different environments during the model training, we make the feature extractor play a mini-max game against the domain discriminator. Eventually, the domain discriminator will be cheated by the feature extractor. As a result, the domain-specific features are removed and the common environment-independent features are remained. Note that there is a hierarchically weighted combination module in the feature extractor to selectively integrate different views representation according to their contributions to the model's performance. If you want to know more details about our model, please refer to our paper. I'd like to illustrate our experiment settings. We collect both Wi-Fi signals and ultrasound signals from 3 different rooms, and there are 8 volunteers perform 8 daily activities and 1 undefined activity in the marked activity area. This is the result. Note that the data for the training is collected from room 1 and room 2. The data for the testing is collected from room 3. We report the results on 12 heterogeneous views and 9 Wi-Fi views. We can see that our model outperforms the baseline with a large margin. We also conduct many other experiments To study the limits of our model, please refer to our paper. Lastly, we conclude our paper as follows. We identify the opportunities as well as challenges in device-free human activity recognition with heterogeneous multi-view data. We propose DeepMV, a unified multi-view deep learning framework to learn informative representations of heterogeneous device-free data. DeepMV can combine different views information weighted by the quality of their data and extract environment or subject independent information to improve the recognition performance. We set up a testbed using COTS, Wi-Fi, and acoustic device and collect real-world activity data. We empirically show that the proposed model can efficiently recognize activities and outperform the state-of-the-art human activity recognition method on the collected dataset. That's my presentation. Thank you very much.